Section 3.4 is talking about parallel and perpendicular lines. Theorem 3.8. If two lines are parallel to the same line, then they are parallel to each other. So if I have A parallel to B, B parallel to C, then I can conclude A is parallel to C. Theorem 3.9. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So if M is perpendicular to T, there's your perpendicular symbol, and N is perpendicular to T, then therefore M and N would have to be parallel to each other. Let's take a look at an example. First example says a carpenter plans to install molding on the sides and the top of a doorway. The carpenter cuts the ends of the top piece and one end of each of the side pieces at 45-degree angles as shown. Will the side pieces of molding be parallel? Explain. According to my top theorem, Theorem 3.9, in order for these sides to be parallel, they would both have to be perpendicular to the top. And if they're going to be perpendicular, then they have to form 90-degree angles. Well, these do form 90-degree angles, which makes them perpendicular. So, according to Theorem 3.9, since they both are perpendicular to the top, then I know the sides would be parallel to each other. So big pieces, I have to have my sides perpendicular to the same in order for them to be parallel. Alright, pause the video and try the next question. In the got it question, it says, can you assemble the pieces at the right to form a picture frame with the opposite sides parallel? Explain. So here I have my picture frame, and I have 30s on this side and 60s on the top. In order for these to be parallel on the sides, you would need to form 90-degree angles. So according to the Theorem 3.9, the opposite sides would be parallel since they are perpendicular to the top and the bottom. Okay, next theorem. Theorem 3.10, the perpendicular transversal theorem. It says, in a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So in this case, N is perpendicular to L, and I know L and M are parallel. So therefore, N has to also be perpendicular to M. Let's take a look at some examples. Here it asks, the Main Street intersects Avenue A and Avenue B. Avenue A is parallel to Avenue B, and Avenue A is also perpendicular to Main Street. How are Avenue B and Main Street related? Explain. So the first thing I would have you do is go ahead and draw this picture. So pause the video and do that, unless you already saw me do it. So your picture should look like this. Main Street is intersecting A and B. A has to be parallel to B, so you'd want to make sure that they look parallel. And then also, A is perpendicular to the main street, so I put my right angle in here to show that it's perpendicular. Now it's asking, how is B related to Main Street? Well, according to Theorem 3.10, that perpendicular transversal theorem, if I know one line is perpendicular to another line and that same line is parallel, then the second line that's parallel has to be perpendicular to the main street. So B, Avenue B, and Main Street would have to be perpendicular. Pause the video and try the last question. In the last question, that gives you this diagram, and it says A, B, and C are coplanar. What conclusion can you make about those lines? Well, they are both perpendicular to the same line, so therefore they would have to be parallel, and that would be according to Theorem 3.9. Okay, so not a lot going on in this lesson, but important things. So making sure you know when you have parallel lines or if you have an extra perpendicular line.